We're going on to topic 6. This is included in our curriculum, and it's solving radical equations. We'll go over the principle of powers, and then equations with one radical and two radicals. So these are radical equations. It would be an equation that somewhere has an equal sign and somewhere has a radical. And the principle for solving it is the principle of powers. That is, if we raise this side to a certain power and this side to a certain power, in a sense we have a equation still. It's not the same, but equivalent. There is a little problem though, as we'll mention as we go on. Now, what would be the strategy then for solving something like this? And the answer is we want to isolate the radical. So we have the square root of m on this side. We're going to transpose this. It becomes a negative 3 on this side. So this gives us a 6. Now, to get rid of the radical sign, the technique is whatever index number is there, which is a 2, since it's not written, we raise that to that power. So this then becomes the square root of m squared, which is m. So when this index number is 2, and we raise it to 2, it just becomes the radicand. And this is 36. And you might say, wow, that was easy. Yes, it's nice to have an easy one from time to time. You just need to know the procedure. And there we go. And it checks. And you can actually put this in your calculator if you solve for y. It's sort of like finding the zeros here. Now, here's a caution that I mentioned briefly. That is, when you raise both sides of an equation to a power, you can sometimes introduce what are called extraneous roots, answers that are not true. And this occurs because you're squaring sometimes a negative, which makes it a positive. Okay, something like that. So here are the steps. Again, isolate the radical, raise it to the power of the index number, and then check. Okay, so we'll do this one. So we want to isolate the radical. So it's over on this side. So we get x plus 5. Going to transpose this to the other side, and that gives us x minus 1. Okay? We've isolated the radical. Now, the index number here is 2. So we're going to raise this to the second power, and we have to do the same thing to the other side. So again, the nice thing about this is it just becomes the radicand. And this we're going to square using that binomial squaring method. So x squared minus 2x plus 1. Now we're going to integrate this to this side, and we get x squared minus 3x, because this comes over as a negative x. This comes over as a negative 5. negative 4 equals 0. Again, we're going to find the zeros. We have a quadratic equation. So we're going to factor this. And this is x 4, 1. This is going to be a negative, and this is going to be a positive. So we equate each of these to 0 using a technique we had earlier. So here it's just transpose opposite signs, and here it is. Now, what we need to do is check these to see if in fact they both work. So here this will be a negative 1 equals the square root of 4 plus 1. So this is negative 1. This is going to be 2 plus 1. Well, this one equals 3, and this equals negative 1. So that's not a solution. Let's try this one. This is going to be 4 equals the square root of 9 plus 1. So 4 equals 3 plus 1. That one checks. But notice, you did all of the work. You did it all correctly. But when you went to check it, you saw that one of your answers didn't work. That's why it's important to check it. Okay? Yep, they print very well. Now when we check it, the 4, we said, is true, while the negative 1 is false. So the solution is only 4. Don't put in there a negative 1, because they'll count that wrong. Now they're giving us the graphic approach, which we are not going to need. So now let's look at this one here. This is a little variation of it. I like to see these written this way. The third root of 3x plus 4 minus 2 equals 0. Now remember, this is a good ways too, but I like it this way. Why? Because you actually see the index number, 3. All right, so first thing we're going to do is bring this to the other side as a positive 2. So just transpose that to the other side. So that's what we have. Now, again, this is just another form of that. But I like this because the index number is 3. We're going to raise it to the third power. So this then becomes the radicand. 3x plus 4 equals 8. We're going to subtract 4 from both sides, and that gives us 3x equals 4. So x will equal 4/3. Okay? And that was pretty easy. Now again, they're using the fractional exponent form. They transpose the 2. And again, they're taking this 1/3 and again having it in that form. It's 1/3 times 3. So these cancel out. And so it's similar to what we've done. I like it the other way. again, I don't like the fractions written that way, but that's good here. And it can be solved graphically as well. You're finding the zeros. Now, how about if there are two radical terms? How are those done? Well, again, you isolate one first, use the principle of powers, then clear, and then work with the other radical. And I'll show you this and check it. Okay, here we go. This is going to be a little bit challenging, but it'll be okay. So we have the square root of x plus 3. I'm going to move this negative term to the other side, and that's going to be the square root of x minus 2 plus 1. So I'm taking this to the other side and putting it there. Now, what do? Well, we square both sides. This is the easy part. It just becomes x plus 3, the radicand. Now, we're going to square this binomial. It just becomes this. This squared is that. Now we multiply these two together, double it. This is from chapter 5. Well, similar. And we square that last term. Okay? Now what we want to do is isolate this radical. But let's group like terms first. So we have x plus 3 equals x. Now I have a minus 2 and a plus 1. That's going to give me a negative 1. And then plus 2, the square root of x minus 2. And I want to get rid of these on this side to that side. So if I subtract x from both sides, the x's just cancel out. Now I'm going to add 1 here and add 1 here. This gives me 4 then. Okay, I just transposed that, gave me the 4. Now, can you see I have a 2 here and a 2 there? So I can divide everything by 2. Let me change colors here. Divide this by 2, divide that by 2. So I get 2 equals the square root of x minus 2. There we go. No, so much easier. Now I'm going to square both sides. So this now gives me 4, and this just gives me the radicand. Again, the index number just becomes the radicand. And it wasn't too bad after all. Again, sometimes these can be very tedious. This one wasn't too bad. Okay. Square both sides. And group like terms. Divide by 2. And square both sides again. X equals 6. Again, not too bad. And that was a real short one.